This may be the tiniest spacecraft ever built by ESA, but its new technology on board is paving the way for much larger future satellites. Despite being only the size of a television set and weighing just 100 kilograms, the Proba satellite, Proba standing for Project for On-Board Autonomy, is the first fully autonomous ESA spacecraft. This means it will operate in space virtually unaided, performing everyday tasks such as navigation, payload and resource management, with little or no involvement from ESA's ground controllers. Proba not only has a mind of its own, it will also boast an extensive research program with its diverse range of scientific instruments, some of which have never before been used in space. What's more, the data from these instruments will be distributed to scientists on Earth via a web server and the internet.
The primary objective of Proba was to test avionics technology in orbit. However, we didn't only want to fly just a pure technology mission, we also wanted to give the opportunity for other useful space experiments to be done, and we did a call for ideas, which we selected essentially Earth observation related payloads to put on Proba.
Proba was built by Verhaert Design and Development from Belgium, with the help of other European companies. It will be put into an orbit 800 kilometers above the Earth as a piggyback payload on an Indian launcher around the 15th of October. There are 5 instruments on board. 2 will monitor the space environment near the Earth, and 3 instruments take images of the Earth's surface, mainly of land areas. The intriguingly named CRIS instrument, for Compact High Resolution Imaging Spectrometer, is one of the instruments taking images of the Earth, and is of interest particularly in recording features of vegetation and aerosols. The objective of CRIS is to validate techniques for future bigger imaging spectrometer missions that will help with precision farming observations and yield forecasting. DEBI stands for Debris in Orbit Evaluator. It will serve the increasing need to monitor tiny particles of space debris that swarm around the Earth and pose a potential impact threat to satellites and manned space missions. 2 sensors on Proba's external walls measure the amount of debris particles in polar orbit. The SREM instrument, for Standard Radiation Environment Monitor, will monitor electromagnetic radiation and atomic particles in polar orbit, which is important data for the design of satellites. There are also 2 images on board, a wide-angle camera, WAC, and a high-resolution camera, HRC. The 5 instruments are controlled by a brand new computer system, 50 times more powerful than that on ESA's full-size solar observing satellite, SOHO.
The images on Proba are stored on the spacecraft. When it passes over the ground station, either at Redu or eventually Kiruna, the images are sent to ground and stored on the web, on a server which is connected to the web. These images can then be accessed by users. In some cases, in particular one of the payloads, there is some pre-calibration done by ESA first.
Requests by scientists for taking data over specific regions are sent to Proba from Redu. The satellite will then automatically calculate the attitude profiles, resource requirements, and the time at which it will be over the sites that are to be observed. Proba is part of ESA's effort to promote technological flights using small spacecraft, and it's hoped that it will demonstrate that microsatellites can efficiently combine in-orbit technology with a useful research mission.